Look at your software delivery pipeline. The real bottleneck isn't in your GitHub Actions runtimes or your test execution reports. It lives in the dark, empty gaps between those systems. We call it the handoff tax. This chart shows the true anatomy of a 3-hour release cycle. The actual execution, tests, builds, deployments, takes about 20 minutes. The remaining 2 hours and 40 minutes is pure manual coordination. That massive chunk of time is just humans waiting on other humans. It is Slack messages left unread for 25 minutes, Jira comments sitting idle, and release managers waiting for someone to confirm what they already know before they can proceed. To fix this, you have to stop treating these communication gaps as an unavoidable cost of doing business and start treating them as a product. And those narrow, predictable handoffs are exactly what focused AI agents are built to automate. By shifting our focus away from optimizing code execution and toward automating these human handoffs, we took a bloated 3-hour release cycle and crushed it to just 18 minutes. Here is the exact blueprint of how we built it in 10 days. We mapped every moment someone needed information from another, identifying 4 handoffs costing 40 minutes latency: failure triage, hotfixes, quality gates, and release readiness. Instead of monolithic AI, we built 6 focused agents passing data between GitHub, Slack, Jira, and Llama. To build our first agent, handling failure triage, we needed a solid training corpus. We pulled 6 months of historical CI logs, but had to scrub and structure that raw data before it was useful for prompting. With the data cleaned, we used LangChain and a local Llama 3 model. Now, within 90 seconds of a failure, the system reads the logs, classifies the issue, queries Google Sheets for historical context, and appends a rolling flakiness score. To keep the agent's 87% accuracy rate from causing disruptions, we built a human-in-the-loop fallback. Developers click a thumbs up or thumbs down on the automated Slack summary, feeding corrections back into the prompt cycle to continuously catch hallucinations. By isolating that initial failure triage with a localized LLM and a simple manual feedback loop, the highest friction bottleneck in the entire release drops from an average 34-minute wait down to under 2 minutes. Next, we moved into days 6 and 7, shifting our focus to hotfix validation agents to ensure we never run a full test suite when a targeted run will do. We created a dedicated JSON configuration file right in the repository. This file explicitly maps specific application code files directly to the test shards most likely to be impacted by changes. When a pull request is tagged as a hotfix, our third script uses the GitHub API to read that mapping and trigger only the relevant shards, drastically reducing test execution time. But there is a trap here. Static file-to-test mappings will silently break if your pipeline topology changes, or if developers add new test files without updating the registry. To solve this, you have to mandate strict hygiene. We added a CI linting rule that instantly blocks any new test commits unless the corresponding JSON mapping file is updated in the exact same pull request. Moving into days 8 and 9, we built the quality gate agent. Before releasing, it checks test coverage in CI, checks performance benchmarks, pipeline security scans, and open critical Jira bugs. Finally, our release readiness agent aggregates these checks, posting a single comprehensive go, no-go summary card directly to the release manager Slack. The release manager has one message with everything they need, completely eliminating the 28-minute context switching penalty of manually checking multiple dashboards. Day 10 is where the isolated pieces finally connect. We take the 6 standalone scripts and integrate them into a single cohesive workflow. To prove operational capability, we ran the entire suite of agents end-to-end against a staged release, allowing us to watch the handoffs trigger in real time. During integration, we verified 3 specific success metrics: the execution timing of the scripts, exact formatting of Slack UI outputs, and data accuracy across all APIs. Passing this end-to-end integration test is the absolute requirement. It is the moment these tools graduate from experimental Python scripts into trusted production infrastructure. Over the next 3 weeks of production, the numbers proved the concept. Across 23 releases, the median cycle time officially dropped to exactly 18 minutes. The operational burden plummeted alongside it. We used to require 3 engineers actively managing communication during a release window. Now, 1 engineer simply monitors a Slack channel and intervenes only when a script flags a required decision. Fixing a slow release cycle rarely requires faster test runners or better caching. The execution pipeline is usually fine. You have to automate the white space between the steps. AI agents, when tightly scoped to narrow, specific tasks, are the ideal tools to eliminate that manual coordination entirely. They replace the Slack message someone had to write, read, and act on with an automated action that happens instantly. If you want to build this kind of efficiency into your own delivery pipeline, subscribe to Automate and Elevate on YouTube for weekly insights into AI-powered QA, CI/CD automation, and modern SDET tools that ship.